Okay, students, so let us start with a new chapter, electrochemistry. Electrochemistry. So, what do you mean by an electrochemistry? As the name suggests, no, you can understand there are two types of energy transition is there. One is electrical energy is converted into chemical energy, and another one chemical energy is converted into electrical energy. So this is basically an energy transition between a chemical energy and a electrical energy. So let us discuss now definition of electrochemistry. Electrochemistry is the interconversion between electrical energy and chemical energy. Okay, so basically we can say there are two types of cells are there in electrochemistry. One is electrolytic cell. One is electrolytic cell. Electrolytic cell. Another one is galvanic cell. So in an electrolytic cell, you will see a energy transition from electrical energy. Electrical energy is converted into chemical energy. Chemical energy. While in a galvanic cell, you will see chemical energy is converted into electrical energy. Okay, so that's a first introduction to electrochemistry. It is basically, it's an intertransition between electrical energy and chemical energy. So we will see a chemical energy will be converted into electrical energy, and electrical energy will be converted into chemical energy. So electrolytic cell is electrical energy to chemical energy. In galvanic cell, chemical energy into electrical energy. Okay. So let us start with the electrolytic cell first, because now that's our initial part where we can discuss what is electrolytic cell is all about. So before going into that, let me discuss some basic term. What do you mean by a conductor? What is mean by a conductor? So this already we know. Let us rewind it. Conductor means no. These are the substance which allow the passage of electricity. Okay. For example, metals. Metals are good conductor, which means no. If you apply some electric current at one end, you will see the electrical energy will be transferred to the other end as well. So there is a electrical energy has been transferred throughout the metal. So that means metals are good conductors. How can you define conductor? Conductors are the substance which allows the passage of electricity. So how can you define insulator? Insulator is just the opposite, where no, you cannot say nil conduction something, you can say the substance are poor conductor of electricity. The insulators are poor conductors of electricity, that we can say they are insulators. Okay, so that's the way you can define conductors and insulators. Okay, now we can think how this conduction is possible, because in metals we saw electricity has been passed through from one end to other end. So there are someone is should be there to take the electric current or carry the electric current from one end to other end. So who takes that? Who's doing that? In metals and in graphites, etc., alloys, etc., you will see the charge carriers are electrons. So the free electrons actually carrying the electric current from one end to other end. So nicely, the conduction is possible because of the presence of free electron. We know some of the salt solution. No, we know sodium chloride aqueous solution conduct electricity. So some of the ionic compound solution also they conduct electricity. So what may be the possibility? There, no, the ions acting as a charge carrier. Ions carries the electric current from one end to other end. We know no pure water cannot conduct electricity because there is no ions is present. Once some sodium chloride or some salt is added into the water, you will see now conduction mechanism is possible. The solution become conducting in nature because no free ions are present. By dissolving sodium chloride in water, you will see ions are separated. Now that no ions can carry the current from one end to other end, which means no they become good conductors. So there are two types of conduction. We can say conductions are by means of two means. What are they? One is electronic conduction. Another one is electrolytic conduction. Electrolytic conduction. So these are the two types of conductions. Okay, that means no electric current pass from one end to other end. So there are two ways no the conduction mechanism is possible. One is electronic conduction and another one is electrolytic conduction. So what do I mean by electronic conduction? Electronic conduction means no here electrons are the charge carriers. Electrons are charge carriers. So they carries electric current from one end to other end. We can say free electrons. Bonded electron will not carry. So it is a free electrons are responsible in electronic conduction. While now we can say it is the free ions. Free ions are the charge carriers in electrolytic conduction. So that's the way you can imagine. In electronic conduction, electrons are the charge carrier. In electrolytic conduction, which is the free ions are the charge carriers. Okay. So let us discuss one more important point related to that. Now here there is no real permanent chemical change. There is no permanent chemical change involved with the electronic conduction. But now in electrolytic conduction, there is no electrolytic conduction. You will see a permanent chemical change. Why it's so? Because now here you will see a new substance are forming. Especially we will discuss the electrolysis of molten NaCl. In a molten NaCl, you will see sodium metal is depositing at the cathode and the chlorine gas is evolving at anode. So there is new substance are forming from sodium chloride. In sodium chloride, sodium ion and chloride ions are existing. So sodium ion goes to, that is cation, moves to, sodium ion is cation, right? So cation moves to cathode and anion moves to anode. So this sodium ion undergo reduction at cathode. Reduction means gaining of electron. Electrons are gained and they reduced to sodium metal at cathode. Okay, while on the anode we will see anode always oxidation takes place. Anode is an electrode where always oxidation takes place. Cathode is an electrode where reduction takes place. So here at anode you will see oxidation of chloride ion takes place because chloride ion is negatively charged that attracted to the positive electrode, that is anode. So there you will see chlorine gas will be evolving by the oxidation of chloride ion. So we will discuss that. So there you will see a permanent chemical change. Okay, next point now, the conductance. Talk about conductance. That's no one of the interesting point. Conductance, conductance decreases. Conductance decreases with the increase in temperature. With the increase in temperature. While here you will see conduction increases. Here conduction increases with the increase in temperature. So that's a difference you will observe in a electronic conduction. As the temperature when you increase, you will see the conduction decreases. This is something that you can imagine, no? The free flow of electron is responsible for the conduction, right? So when you increase the temperature, no, there are so many electrons are there. When you talk about 1 mole of sodium, let me say 23 gram of sodium. 23 gram of sodium contain no Avogadro number of electrons. So there are so many electrons. 6.022 into 10 to the 23 valence electrons will be there. Still more will be there, but now talk about valence electron. It is 6.022 into 10 to the 23 electrons will be there. So that much electron now moving very fastly when the temperatures increase. So it has to move. The movement should not be restricted. If the electrons can able to move freely, means no conduction is possible. But when the temperature increases, mutual collision of electron, everything will take place, which means no, it cannot able to move as freely as we did no in the normal temperature. That why when you increase the temperature, metallic conduction will decrease, or we can say the resistance increases. Resistance increases with the increase in temperature, while the opposite here resistance decreases. Resistance decreases with the increase in temperature. Okay, with the increase in temperature. So why so in electrolytic conduction? We already discussed in electrolytic conduction the mechanism is actually the mechanism is actually because of the free ions. So free ions are required, right? Free ions are required in a electrolytic conduction. So we know cations and anions are always attracted each other by strong electrostatic force of attraction. So there will be strong attraction will be there. Which means now when you increase the temperature, that increase in temperature helps to break that the electrostatic attraction between cations and anions. Which means now the conduction become more easier if you increase the temperature, because now it helps to separate into free ions. Okay, there is no real attraction between cation and anion. If that is no lesser the attraction, more will be the conduction. So that's the case. When you increase the temperature, actually in an electrolytic conduction, the resistance decreases. Or now we know conductance and resistance are always opposite to each other, right? So conduction always increases in electrolytic conduction with increase in temperature. So that's the basic start as far as the electrochemistry is concerned. There are two types of conduction. One is electronic conduction, another one we can say electrolytic conduction. Okay. So please note down the points that you require. Talk about examples. Please note down the examples. Examples are in electronic conduction. The examples are there are metals and alloys, and then we can say graphite are the good examples for a electronic conduction. Alloys, we know it may be a metal combination when two or more metals are uniformly mixed to form a homogeneous solution, that solid solution, that we can say alloys, or it may be metal or non-metal combination. So such are the examples for the electronic conduction. Talk about electrolytic conduction. Here you can say salts, acids, bases. These all are example for a electrolytic conduction. So here now one point you can imagine, because now I can say now by saying what is electrolyte, then you will see now this especially salt, now they can exist, they are existing as solid, right? So in the solid state they do not conduct electricity, because now in solid state cations and anions are strongly attracted each other, which means no, they cannot able to freely move in the solid state. That why when you melt it, yes, some attraction has been broken, which means now it behave, it's becoming a conductor. Similarly, in aqueous solution, sodium chloride dissociate into ions, which means there also a conduction is possible. So that's the way you can think in a electrolytic conduction, no, especially acids, base and salts. We can say salts, more example. Salts conduct electricity in the molten form as well as in the aqueous form. But in the solid form, they do not conduct electricity because the free ions are not possible. So let us define electrolyte first, then we can say, then we will understand now. Okay, so what is an electrolyte? Electrolyte means no. These are the substance which will conduct electricity in the molten form or aqueous form. Such substance we can say electrolytes. Okay, electrolytes are substance which will conduct electricity in the molten form. Molten form means no, we just melted it, so it be converted into liquid form, right? So molten form or aqueous form. So such substance we can say electrolytes. Examples are acid, base and salts. Acid, base and salts are example for electrolytes, because though in the solid state they do not conduct electricity, but in the liquid form or in the aqueous form they conduct electricity. So remember why it's so, because no, first of all ions has to be separated, then no, ion has to freely move. So in the solid state the free movement of ions is restricted, because no, yeah, the ions are strongly attracted each other by electrostatic force of attraction in the solid states. That why when you pass electric current in a solid NaCl, it do not conduct electricity. You dissolve sodium chloride in water. Now you check the conductivity, you can understand that they conduct electricity. So that is electrolyte is all about. Okay. Now let us define electrolysis. Electrolysis. What is electrolysis? As the name suggests, no, electrolysis means no, you can imagine an electrolyte, you pass electricity through it. Okay, the process of decomposition of electrolytes by passage of electricity, you can say that is called electrolysis. So this word you will quite often you will see. So the major point now, electricity should be there, external electricity is required. So you passing external electricity and splitting the compound, now you will see ions are separated. That ions is the responsible for the conduction mechanism. So electrolysis is the passage of electricity through an electrolyte, or we can say the decomposition of passage of electricity through an electrolyte, so that it's now splitted into ions and conduction is possible. So simply now the process of splitting of an electrolyte into components, that we can simply say electrolysis. The use of electricity is there. Okay. Please note down the important points that you required. Okay, along with the classes. Then no, let us discuss the simplest example to understand no, what is this electrolysis is all about. Let us start with the electrolysis of molten NaCl. Electrolysis of molten NaCl. Electrolysis of molten NaCl. Okay, this is something now you can easily study because now there is no real complication is there. Because you imagine electrolytic cell, a big vessel, okay, in which one metal electrode will be there, which is connected to the positive terminal of the battery that we call anode. So this is the battery where it is connected to the positive terminal that become anode. That's how we can define an anode in an electrolytic cell. Anode is an electrode which will conduct electricity in the sorry. Anode is an electrode which is connected to the positive terminal of the battery, while cathode, no, it is cathode is an electrode, metal electrode which will which will connected to the negative terminal of the battery. So anode means the electrode connected to the positive terminal. Cathode means the electrode connected to the negative terminal. Okay. So now we can see in the electrolytic cell. This we can see electrolytic cell in the vessel. We actually taken molten NaCl. Molten NaCl is taken. What good about molten NaCl? There is only two possible ions are there because molten form definitely it is all about sodium ion and chloride ion. So Na plus ion is there and the chloride ion is there. These are the two types of ions which is present in the molten NaCl. Okay, now we know cathode is negatively charged and anode is positively charged. So cation, that's the way you can remember. Cation moves to cathode, anion moves to anode. So what will happen? This sodium ion moves attracted to the negative terminal and this chloride ion attracted to the positive terminal. So you actually getting now this we know at cathode reduction takes place, at anode oxidation takes place. So let us write now anode reaction. Anode reaction. At anode Cl minus is Cl minus become Cl. No, exactly it's not Cl because Cl monoatomic is unstable. So we can say half mole of Cl2 because Cl quickly combine with another chlorine to form chlorine gas. So half Cl2 that is gas with the release of electron will be released. So release of electron is also oxidation. That's something that you can remember. Oxidation is the release of electron and reduction is the gain of electron. So here you can see electrons are released. So this is simply an oxidation. Remember whether it's a galvanic cell or electrolytic cell, always oxidation takes place at anode and reduction takes place at the cathode. So here you will see chloride ion is oxidized to chlorine. Chloride ion is oxidized to chlorine with the release of electron. You can remember in terms of oxidation number as well. Here chlorine is negative one oxidation state. In the chlorine molecule we know in the elemental form. So in the zero oxidation state, which means there is a decrease, there is an increase in oxidation number from -1 to 0. So that's simply oxidation for you. Now let us think what is reduction at cathode. So let us write cathode reaction. At cathode reduction takes place. What will happen here? Now Na plus ion is moving to cathode. So Na plus ion gains electron. Always know the number of electron released in the anode will be equal to number of electron gained in the cathode. So Na plus ion gains one electron to give sodium metal. Sometimes the number of electron released and number of electron gain will be different. So you have to make it equal. Okay, then only the complete reaction will take place. So Na plus ion gains one electron to form sodium metal. So that is what happening at the cathode, which means sodium metal is depositing at the cathode and chlorine gas is evolving at anode. Remember, to get sodium metal is not easy. No, we discuss in the metallurgy. In the metallurgy, one of the point we always discuss because the alkali metals, alkaline earth metals are highly reactive. Among alkali metals like sodium, potassium is very highly reactive. It's not, it's react vigorously even with the water. So generally in the atmospheric condition you cannot obtain sodium metal in the free states. It's always in the combined form, maybe in this sodium chloride, sodium carbonate, like that, in the ionic form, because sodium wants to convert into an ion. That's a stable form. That why sodium dissolves in water, it converts into ions. Sodium in the atmospheric condition tries to become sodium cation, that is Na plus ion. It tries to move to that state because that is the stable noble gas configuration that you can achieve, which means it will go to that state. Which means here now one of the best method that can synthesize sodium metal. This is the way you can prepare sodium metal. How? If you carry electrolysis of molten NaCl, one of the way. Okay, there are several methods are there. One of the method, molten NaCl is electrolyzed. Then you will see sodium metal will get deposited at the cathode. While at anode, you will see the chloride ion is no oxidized to chlorine gas. You are going to get a chlorine gas at anode, and at the cathode, sodium metal will be deposited. So that is no basic way you can understand electrolytic cell about. Now, if you understand this, no, that's give you a fundamental idea, because what is happening in electrolyte cell. One of the first condition is external electric current is required. You have to supply battery. External electricity should be supplied. Next condition, there should be two electrodes. Generally, inert electrodes are used, like platinum electrode, inert electron, because they're not supposed to react. So otherwise, no graphite electrode. That's no. If you talk about if you want to save money, so that's a better way. Graphites are inert electrodes. Okay, graphites are generally also used as electrodes. That we also say carbon electrodes. So here the point is, no external electricity required, then no anode will be there, cathode will be there. Anode is positively charged electron, cathode is negatively charged electron, because it connected to the positive and negative terminal respectively. Then you will see a positive ion attracted to the negative electrode, negative ion attracted to the positive electrode, which means Na plus ion moves to cathode, chloride ion moves to anode. So there you will see at anode chloride ion converted into chlorine gas, at cathode sodium ion is converted into sodium metal. So that what happens when electrolysis of molten NaCl is carried out. So please note down the points that you want. Okay, learn it as well, because no, you can develop from the fundamental ideas. Okay, now let us move to this. Let us discuss more point. Okay, now the simplest one we discussed. Now the next category that we'll know, I will say electrolysis of aqueous NaCl. Electrolysis of aqueous NaCl. So first one was electrolysis of molten NaCl. This time electrolysis of aqueous NaCl, which means now the difference is in molten NaCl only sodium ion and chloride ion will be there. So when electricity pass, they dissociates. So no ions can move to the respective electrons. So there is no real problem. But here water is also there, because no we dissolves in water, right? So water also can be oxidized and reduced, because no in redox reaction we will discuss that oxidation and reduction of water. So that can be takes place. So it's all about now which species undergo oxidation, which species undergo reduction. That will be very important point here. So talk about aqueous NaCl. Similarly, electrolytic cell, there will be anode will be there, cathode will be there. This time you taken in the electrolytic cell, that is aqueous NaCl. Aqueous NaCl. So definitely sodium ion and chloride ion will be there. Then water also present, H2O, because it's aqueous form, right? So H2O is also there. Remember, H2O can be oxidized. Remember oxidation, oxygen in the -2 oxidation state in water. It is +1 oxidation state. Hydrogen is in the +1 oxidation state. So now it can be oxidized if -2 oxidation state increased from -2 to, now let me say O2, oxygen is formed. Here you can see increase in oxidation number from -2 to 0. So this we can say oxidation, because there is increase in oxidation number from -2 to 0. So that is oxidation. Similarly, if now hydrogen now hydrogen gas is formed as a result of electrolysis. We already studied, right? Electrolysis of water in presence of small amount of acid, hydrogen and oxygen will be released. So here now, oxygen in the plus 1 oxidation state decreased from plus 1 to 0. So that is reduction. And oxygen minus 1 to 0. So that's we can say it's an oxidation. So simply we can say no, there is a redox reaction that was taking place when electrolysis of water is undergoing. So if you balance this 2H2O to H2 plus O2, so no, you will see higher volume of water will be released when no electrolysis of water is carried out. 2 moles of water gives you 2 moles of hydrogen and 1 mole of oxygen. So you will see more amount of hydrogen bubbles. Okay, because 2 moles are forming. So this is now just I discussed related to understand now water also can be oxidized or reduced. So remember that point. So just now back to this point. Here now two types of ions we will see, sodium ion and chloride ion. So now it is observed that at anode the chloride ion is oxidized. Chloride ion is oxidized, and at cathode it is the hydrogen ion. The hydrogen ion is now gets reduced to hydrogen atom. We know hydrogen atom is also is not stable. So here also you will see as hydrogen atom quickly combine with another hydrogen atom to form hydrogen gas. You can represent like this as well, because now monoatomic hydrogen is unstable. So it will combine with another hydrogen atom to form hydrogen molecules. So here you will see it is the hydrogen ion is now get reduced at that is reduction. At cathode reduction takes place, at anode oxidation takes place. So hydrogen ion get reduced to hydrogen gas. You will see hydrogen gas will be evolving at the cathode electrode, and you will see an anode ion which is now oxidized. The chloride ion is oxidized to chlorine gas. What may be the reason? It's all about there are when there is two or more types of ions is there, or two or more species is there will be a competition. Which having higher tendency to undergo reduction, that will undergo reduction. Which having higher tendency to undergo oxidation, that will be oxidized. So that is the general case. Okay, you can understand with that way. Okay, when you compare Na plus ion and reduction of hydrogen ion, we know sodium ion having lower reduction potential, while oxidation of water into hydrogen, that we can say having higher reduction potential, which means among these two species hydrogen ion having a tendency to get reduced compared to sodium ion. That why at cathode you going to get hydrogen gas instead of sodium metal. If you want sodium metal, you have to carry out the electrolysis of molten NaCl. There is no real competition is there. But here you will see that. But at anode, again the point is there is a possibility the water can be oxidized to oxygen. That is also a possibility. But it is found that even though if you compare the oxidation potential, those who are having higher oxidation tendency, that will oxidize. If you really compare with the standard reduction potential value, you actually observe that there is water having more tendency compared to chlorine. Even though they are so much comparable, still there is one important point, still the chloride ion is getting oxidized because of the one important phenomena that we will say over oxidation potential, over oxygen potential, or oxygen over potential, like that. So this means at normal voltage the oxidation of water to oxygen do not takes place. You have to supply higher voltage. That means one point there is comparable reduction potential difference between chloride ion and water in the case of oxidation. There you have to understand the because of the over potential of oxygen, oxygen is not releasing at anode, which we expect, because no higher tendency of oxidation, if you compare the value, it's expected to be that, but it's not so. So that's the point. You can remember when more electrolysis of aqueous NaCl is carried out, you will see chloride ion oxidizes to chlorine at anode and hydrogen gas releasing at the cathode. So that's the point you can remember. So now that's the point. Now first introduction I will have to say in the in the electrochemistry. Now one more point. Now you can easily understand. Now one more point you have to remember always. Whenever you supply electricity, there is no possible deposition or evolution of substance takes place at a anode or cathode respectively. You have to supply electrical energy. You remember this reaction was carried out nicely. You stopped the battery, which means when you cut the electric supply, the formation will stop. So that this electrolytic reaction we will say non-spontaneous reaction. This do not takes place naturally. If you put sodium, naturally sodium will react with water or no moisture or oxygen to form sodium ion. That's a natural tendency of sodium ion. But the reverse, sodium ion converted into sodium metal, that's not a natural reaction. That do not takes place naturally. So that's the point you can remember. Here as long as you supply electrical energy, there will be deposition or evolution of substance will take place. When you stop electrical current, the deposition of substance also stops. Okay, that's one important point you can remember related to this. Okay, so just discuss one more point related to the substance which is. Now let us discuss the electrolysis of different salt. We discussed sodium chloride, right? Now if we carried out electrolysis of different aqueous electrolysis of different aqueous solution, aqueous salts. Now let us discuss one by one. First one talk about sodium sulfate. Na2SO4 is carried out. This is our salt. And electrode use. Electrode use is it is the inert electrode, that is graphite electrode or platinum electrode, you can imagine. Inert electrode is used where you observe at cathode water. Water is reduced to, reduction of water means electron should be added. Water is reduced to hydrogen. Hydrogen gas and hydroxide ion. This is water forming at cathode and at anode. You will see at anode you will see again water is oxidized. Water is oxidized to oxygen gas. O2 gas plus 2H plus ion. Remember oxidation means electron is released. So 2 electron. Now try to write the balanced chemical reaction. If I missed, you have to check. Okay. So here interesting, very interesting point. Here sodium sulfate that we have taken, and interestingly you observing that it is not the sodium metal or not the sulfate ions not getting reduced or oxidized. It is all about water is undergo reduction at cathode and water undergo oxidation at anode. So there you have to understand the sodium ion definitely having the lower reduction potential value compared to hydrogen. So there if you compare in that manner, it is not the sodium ion is getting reduced, it is the water is getting reduced. So that's the point you can remember. Okay. Next point, talk about sulfate ion. You see, oxygen is evolving here, which is now contrary to the previous case. So that means there is a large difference in the reduction potential between sulfate ion and water when you talk about oxidation to oxygen. So there you will see sulfate ion more have a tendency to undergo reduction. Okay, especially in the If the concentration varies, you will see some change. Normal condition, at normal concentration, reduction potential of sulfate ion is larger, which means they have more tendency to undergo reduction rather than oxidation. So there you will see, water is getting oxidized. So that's the first point. That's the first salt we discussed, sodium sulfate solution. Next, copper chloride, CuCl2. CuCl2, this time again inert electrode is used. There also you will see one difference where copper 2 plus ion this time getting reduced to copper, while chloride ion is getting oxidized to chlorine. So the difference is here now you have to compare the electrode potential again. Here now the copper ion, we know copper ion having positive reduction potential value, where while hydrogen it is 0. So which means copper having higher tendency, copper ion having higher tendency to undergo reduction. So it's not the water which is reduced, it is the copper ion getting reduced at the cathode. So Cu2 plus ion converted into Cu. While chloride ion is converted into chlorine gas, okay, in at anode, which means again the same previous case, because it is the chloride ion and water will be there. So because of the over potential, it is not the oxygen getting oxidized, it is chloride ion getting oxidized in a electrolysis of aqueous copper chloride. Let us discuss the next one, copper sulfate. Copper sulfate, not two cases I am discussing. One is inert electrode is used. One inert electrode is used, the same reaction, copper ion get reduced to copper. Okay, the water getting oxidized to oxygen with release of electron. So here now you can easily compare again the sulfate ion comes, so same case. Okay, here copper ion having higher reduction potential value, so it get reduced and water getting oxidized. So that's the case, copper sulfate using an inert electrode. The same case, copper sulfate this time using a copper electrode. If copper electrode is used, what will happen? There now copper itself can undergo reaction. Okay, copper itself can undergo oxidize and reduce, which means you can imagine a copper anode, copper cathode. So definitely here both oxidation and reduction are so copper ion taking place. So to at cathode Cu2 plus ion get reduced to copper, and at anode the copper metal is oxidized to copper 2 plus ion and 2 electron. So this is the different case where the electrode use is not the inert electrode. This time the metal itself be taken as electrode. So nature of electrode, the presence of electrolyte, and the reduction potential, everything going to be a factor when you talk about anode and cathode reaction in a electrolytic cell. So here you just compare copper sulfate in inert, copper sulfate in copper. Copper sulfate in inert electrode, you will see copper metal like the other case. But that time it was oxygen was oxidized, oxygen was produced at anode. But here at using a copper electrode, you will see a change where copper metal is getting deposited at the cathode, and it is the copper is getting oxidized to copper ion at the anode. Okay, so this is one of the basic starts for the electrochemistry. Now some of the basic fundamental points that I discussed. If any doubt is there, you can ask. Okay, quickly also please try to read. Reading is very important. You have to read the textbooks and possible textbook that you can get. Okay, reference you can check. Also you have to practice as well. Okay, thanks for listening. Let us meet in the next session. Okay, thank you.